It's important to carefully plan out how databases will be used in the Amazon Web Services cloud. And so it's important to focus on database capacity planning. You might have web applications or line of business apps perhaps even only used internally. Maybe they run on mobile devices and send data to a central database. Whatever the case might be, you need to know how databases will be used to perform database capacity planning. This means thinking about the amount of data that's going to have to be stored, and that brings into question for how long. If we store data in a database for long periods of time, we're going to need more space to accommodate that. Whereas if we have backups that get archived and rotated periodically, that might lessen the amount of database storage space that we will use. We have to think about the frequency of data. Are we ingesting a live stream of data over the internet? And so we have to make sure that we have quick or elastic rapid provisioning of database storage. We also have to think about the type of data that will be stored. Is it going to be structured data? For example, do we have a customer sign-in portal on our web application that will always store customer information like email addresses, phone numbers, payment methods, and so on? Or do we have unstructured, unpredictable data on a large scale of many different types, so less structured? That's going to determine what type of database you use. More on that in a minute or two. Then we have to think about storage and database connection capacity. How many concurrent connections might we have during peak usage? That might be certain times of the day. The pattern might be certain times of the week, certain types of the month, only when there's sales if you're in retail, or only seasonal. You have to monitor your application and backend database usage over normal usage to determine what the standard baseline is. That will vastly improve the overall performance if you apply that learned knowledge to your database capacity planning. Even if you have metrics for that type of performance on premises, perhaps because you've run a solution on-prem for the last couple of years, and now you're going to migrate it into AWS, that's still going to be enormously helpful to help you right-size your solution in the AWS cloud. And of course, we have to plan for failure. It's inevitable over time. Things will fail, they will slow down, and so we want to have a proactive approach to that. Resiliency to failure means a couple of different things. It could mean, do we have server failover in an active environment, where you have a couple of servers always up and running? If one fails, the other one kicks in immediately. Well, we'll talk about the RDS proxy in a couple of minutes, which kind of deals with that. Resiliency to failure also means other things, like do you have an incident response plan to minimize the RTO, the recovery time objective, to get things up and running as quickly as possible? Do you have multiple database replicas? Perhaps some are read-only, some are read-write. How often are you backing up your data? And where is that data backup stored? The last thing you want is everything available online all the time, because a ransomware infection could also affect your backups. All of these things we're talking about end up being fine-tuned granular details depending on the type of database you're using and how you're using it. Now, part of planning is the type of database you will use. There are two general categories: NoSQL databases. NoSQL means not SQL. An example of that would be DocumentDB or DynamoDB in the Amazon Web Services cloud. A NoSQL database either does not have a structured schema, or it has a loosely structured schema. The schema in a database is a blueprint for what will be stored in it. Now think about a standard SQL-compliant database. SQL meaning structured query language. In AWS, there are many SQL-compliant solutions available through Relational Database Service, or RDS. This is a managed service where you can run databases, and Amazon takes care of the underlying virtual machines that run it. There are some variations on that where you can have a bit more control of the underlying instance, but generally, it's a managed service. But SQL uses a structured schema. The blueprint or definition of what will be stored in the database is very rigid and specific, such as in the customers table, we will store the customer ID, the date they became a customer, the first and last name, email address, phone number, payment preferences, that type of thing. And you can only store that type of information within a table with that type of definition. So it then becomes very apparent when you should use a NoSQL database versus a SQL database, or maybe a hybrid of both for certain parts of an application. Pictured on the screen, we have a screenshot of RDS database engine options. So when you go to deploy relational database service in AWS, you will have the option between a number of different database engines like Amazon Aurora, MySQL, MariaDB, PostgreSQL, Oracle, and Microsoft SQL Server. Now, depending on your selection, will determine what you select down below for the version of that engine. You might need a specific version of that database engine to support some aspect of your application. Now, if you're the AWS Cloud Technician and not the database or web app developer, you need to talk to them to find out what the appropriate selection is here. And there are more options to select beyond just this, such as the listening port, whether the database should be publicly accessible over the internet for remote management from on-premises. And you might determine that, well, I already have some licenses for Microsoft SQL Server that we will no longer be using on premises, so there is a bring your own license, a BYOL. You'll have some other options down below where you can specify things like database encryption, database backups, and so on. One of the things that is very helpful with database capacity planning is simply monitoring data usage patterns over time. Now, you can set that up and even receive notifications when certain metrics exceed a certain value. You can do all of that using Amazon CloudWatch. You might also consider sizing databases so that they have some extra storage, memory, and compute power always available to accommodate unpredictable demand spikes. Now, if you're using a database solution that supports automatic scaling based on usage, then that might already be taken care of. You should consider the average concurrent number of connected users over time during normal usage. Again, setting a baseline of normal performance, because that's going to help you so much. Otherwise, you're guessing. You are working in the dark when it comes to trying to right-size your database solution. When we talk about the amount of data that the database will handle, we're talking not only about what will be stored, but also the amount of data into and out of the network on a daily basis. That also has cost impacts that we need to be aware of, depending on the amount of data that we're talking about. We might consider using provisioned IOPS storage versus the older, slower magnetic storage to address busy disk I/O usage. IOPS stands for input and output operations per second. More IOPS means quicker throughput in the underlying disk subsystem. Now, depending on your database environment, it might be heavy on writing, and so you need to use a high provisioned IOPS value. Or maybe your database is more on the querying side, where you have in-memory caching, where there is less disk I/O. So think about usage patterns for how you will be using the database. And then you can get very specific with the actual structure of the queries themselves. Are the queries created in an efficient manner so that we focus on querying, sorting, and grouping on index values? If not, you might want to go back and configure new indexes for things you search for frequently. In a perfect world, you would have enough memory or RAM allocated to your database solution so that your most common working set of database data is resident in memory. Not all of it all the time, but the most common working set. If it can be retrieved from memory, that's going to be much quicker, thousands of times quicker actually, than retrieving it from even the fastest provision IOPS disk subsystem. Now, one tip I've learned to rely on when it comes to that is using the CloudWatch metric named read IOPS. So what are the disk I/O operations per second for reading? That should be a low value if most of your working set is in memory most of the time during normal database load. And again, the key is under normal database load over time. Well, how long? What's common is if you get 1 week of normal usage of a database solution. Pictured on the screen, we have a screenshot of RDS database compute and storage configuration. It's kind of like setting the instance type for an EC2 instance. So you get to determine the underlying horsepower, the amount of virtual CPUs, and the amount of RAM and the network throughput supported. All very important to pay attention to, and you can change it after you deploy your RDS solution. That's what right sizing is about. Make sure you have the correct horsepower to accommodate your workload with a bit of extra buffer space. Then down below in our screenshot, we have storage options. What's been selected here is provisioned IOPS, where you can specify the amount of allocated storage in gigabytes and provisioned IOPS. Finally, another thing to consider is when to use the RDS proxy. Now, the RDS proxy, like RDS in general, is a managed service. You don't have to set up virtual machine instances or anything like that. That's handled for you. But what is this? What proxy does here for RDS is it pools database connections together in memory to increase connection scalability. Now, what we're really doing here is we have a centralized way to manage database connections while removing it from the backend databases themselves, thereby freeing them up to do what they do best, database stuff. Speaking of centralized, RDS proxy also lets you configure centralized credential management because it integrates with AWS Secrets Manager. And finally, RDS proxy can reduce failover time because it supports something called automatic database failover, which means you don't have to wait for DNS changes to be in effect before you can connect to a new failed over database host.